Okay, so the math dealer here, and today I'm going to do a little polynomial unit test review for my Algebra 2 students. Yep, guys, this is all for you, okay? I'm actually going to break it down into 5 parts, so you actually don't have to sit and watch a 25-minute video, and maybe you'll actually watch all 5 little videos. Okay, here we go. So the first one, part 1, says find all the solutions to the following polynomials by factoring, okay? So with the factoring, you're just recalling that you always got to make sure that you set the polynomial equal to 0. So whenever you're asked to solve a polynomial, you're going to bring every term over to the other side. Remember, when I'm bringing a term to the other side, I have to do its additive inverse. I know, fancy, fun words. Okay, so here we go. First question you always ask yourself when you're sitting down to factor, hey, what's common? So there is a 2x common to both these terms, which is going to leave me with a 9x squared minus 25. And now you're thinking to yourself, whoa, I remember that stuff, right? That's the difference of 2 squares. A squared minus b squared. You've seen pictures. A minus b, a plus b. All right, so that means I'm going to factor this using the difference of 2 squares. Pause the video, guys. It's okay. Go ahead and see if you can get this on your own. All right, welcome back. I hope that's what you did. Now I'm going to set each of these factors equal to 0. Very exciting. And then I'm going to solve for x. I know, super fun. So over here, when I divide both sides by 2, I just get x is equal to 0. Kind of boring, I know. Over here, when I bring the 5 over, it becomes a positive 5. It's going to give me 5/3. And then last but not least, when I bring the negative 5 over, well, when I bring the positive 5 over, I get negative 5/3. So your final answer, your answers to these guys, right, your roots, are going to be 0, 5/3, and negative 5/3. Now, some of you guys were asking me in class about what's the difference between roots and zeros. Pretty much the spelling, right? Yes, exactly. Okay, otherwise, basically, a root is a 0 of the function, okay? Just remember, you have imaginary roots and you have real roots, okay? And we've talked about that in class. Okay, so let's check out this next one. This next one actually has more than 3 terms. So whenever a polynomial has more than 3 terms, hence 4, right? We're going to factor by what we call grouping. All right, so that's when you group 2 together and see if there's anything common. Well, very fun fact, this has x to the 4th common. So I'm going to factor out an x squared minus 4. Check out the next one. The next one definitely has a 9 common, but even better than that, I could factor out a negative 9. The reason why I'm factoring out a negative 9 is because I truly want that resulting polynomial to be the same as the polynomial in the front, or the binomial in the front. Okay, so check it out. I have x squared minus 4 in both of those terms, so I'm sliding that out. X to the 4th minus 9, I know, right? You're like, what? Now I have 2 screamers. X minus 2, x plus 2. That's how I factor that first one. Like I said, pause the video. You know I talk fast. You're used to that in my class, right? X squared minus 3, x squared plus 3. All I'm doing here, you all, is I'm factoring the difference of 2 squares. I'm following this pattern. Box to the squared minus box to the other, or triangle to the squared. Done this before, is box minus triangle, box plus triangle. I know you're getting tired of all these symbols. Okay, now set each of these equal to 0. So I'm setting each one equal to 0, and then I'm going to solve for x on each one. If I can't factor any more, then I'm setting that whole term to 0, and I can't. So I have x is equal to positive 2, x is equal to a negative 2, x is equal to plus or minus the square root of 3. Remember, that was equal to 0. Sorry about that. And then over here, when I bring the 3 over, I get x squared is equal to negative 3. That makes x equal to plus or minus the square root of negative 3. And I really hope you're all about those i's, right? Gives me x equals plus or minus I square roots of 3. And like I said, sometimes our we would write the I on the back. That's technically the correct way of writing it, but I'm not going to cry if you don't write it that way. Okay, so my roots for this one, by the way, my answers, grand finale, the zeros, are 2, negative 2, plus or minus the square root of 3, plus or minus I square root of 3. And I know what you're thinking. You're like, well, can I write it as plus or minus 2? Of course you can. Stop asking those kind of questions. All right, moving on. Check out this last one over here. Now, this one's definitely a little bit more entertaining. And I'll be honest, the one on the review sheet had a little bit of a typo because it would have been really ugly to factor that one. So let's just do this one. First question you ask yourself when you're sitting down to factor is, hey, what's common? So I factor out a 2x squared, right? Which means I'm going to be left with an x to the 6 plus an 18x cubed plus, not 18x cubed, duh. I factored out a 2. Woo, I'm going to be okay. 9x cubed plus an 8. Okay, now I can factor that. Some of you guys remember my little AC method, right? Not just mine, but I'm going to look for factors of 8x to the 6 that combine to get me 9. Of course, it's only 8x cubed and 1x cubed, right? That's the only way you're going to multiply and get 8 and add to get 9. So like we've done in class before, I can replace it. And I'm hoping that you guys don't even need to do this step anymore. But just for those that are just still a little fuzzy with the factoring, I mean, heck, it has been a crazy year, so I'm not going to cry if you are a little fuzzy. Okay? But when I factor that, check out what I have. X cubed plus 8 can factor out, and I'm left with an x cubed plus 1. All right, now here we go. You actually can factor those. If you don't factor them, you're going to lose 2 extra roots in each one. So you're actually going to lose 4 roots if you don't factor this. Okay, so please remember to factor that. The factoring of an a cubed plus b cubed. Now that one has been a while. But you do need to know how to factor that. A plus b, a squared minus ab plus b squared. And follow the pattern. Identify your a and identify your b. All right, so here we go. I have a 2x squared there. When I factor x cubed plus 8, that's x plus 2, because that's a plus b. Then it's a squared minus ab, I miswrote an a, right, plus b squared. Do the same thing with the 1. It's a plus b, a squared minus ab plus b squared. Okay, I cannot stress that enough. If you are a little fuzzy on factoring the sum of 2 cubes, go check out my other video on how to factor the sum of 2 cubes, right? Okay, let's kick this thing out. Woo, I'm running out of breath. Check 2x squared is equal to 0, right? So x squared is equal to 0. That means x is actually equal to 0 as a double root. We talked about that in class. A double root is when something happens twice. Then we have x plus 2. Well, x plus 2 is equal to 0. Gives me x equal to negative 2. So far I have 2 roots here, 1 root here. Okay. Now this one, that is a quadratic. To solve a quadratic, yep, you guessed it. Either I do the quadratic formula or I complete the square. This one I'm going to set up by completing the square. The reason being, and like we said in class, it's because my A is 1 and my B is even. So slide the 4 to the other side, leave a little space, not a big space, just a little space. Take half of negative 2. Half of negative 2 is negative 1. Square it, add it to both sides. Now, you know how to factor this, right? You created it. Seen that before. You get negative 3. Okay, I'm going to have to slide this up. Ooh, I write big. Okay, so now I'm going to say, all right, I get x minus 1 equals plus or minus I square roots of 3 because I'm bringing in a square root to both sides. Remember, if you bring in a square root, you got to pop out your I and don't be rude. Okay, so that's going to leave me with my answers for this little one, for this little thing right there, that trinomial. It's 1 plus or minus I radical 3. Cool. That's 2 more roots. Woo, there's a lot of roots. Oh, wait, yeah, because we need 8 of them. The next one, x plus 1 is equal to 0, x equal to negative 1. So that's another root. I know, right? Crazy fun. Now, I have another quadratic. To solve that quadratic, you guessed it, you got to use the quadratic formula, or you can complete the square. Now, this one, I'm going to do the quadratic formula because my b is not even. Okay? So the quadratic formula, I know you know it, you love it, you call it your own. Over 2a. So I go negative b plus or minus the square root of b squared minus the 4 times the a times the c. Whole thing sitting over 2a. Right? Lo and behold, I get 1 plus or minus the square root of negative 3 over 2. Take your I out. I know. And Merry Christmas, Happy New Year. There's 2 more roots. So I have 2 roots here, 1 root here, 2 roots here, 1 root here, and 2 roots here. Yep, I have 8 roots. Woo! I know that was busy, but trust me, that's a really good problem. All right. Definitely kind of encompasses all the factoring that we've been doing. Sounds good? All righty. This is the Math Dealer. Stay tuned for part 2 video. Yep, you guessed it. Part 2 of a 5-part series.